Liftoff. The clock has started. Roger, 0G, and I feel fine. Godspeed, John Glenn.
Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground.
New possibilities are opening up for scientific cooperation between countries.
2, 1, 0, 0.
Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery, Roger. Go for deploy.
Thanks to you and to everybody in the shuttle program. The crew is go for launch.
Roger. Nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good afternoon. My name is Antonia Jaramillo, and thank you for watching our NASA Social Panel for our Crew Flight Test, or CFT, mission. This will be Boeing's first crewed mission to the International Space Station as part of the agency's Commercial Crew Program. Flying aboard Boeing Starliner spacecraft are NASA astronauts Butch Wilmer and Sunny Williams. Liftoff on a United Launch Alliance Atlas V rocket is targeted for Monday, May 6th at 10:34 p.m. Eastern Time. With us in the room today are a group of digital content creators visiting NASA's Kennedy Space Center for a NASA Social. Throughout their time here at Kennedy, they got a behind-the-scenes tour and are now getting to meet this interesting group of panel of people. To my left are Jim Free, NASA's Associate Administrator, Ian Kappes, Deputy Manager with the Launch Vehicle Systems Office for the Commercial Crew Program based here at Kennedy, Comeau Denker, Associate Chief Engineer at Boeing, Caleb Weiss, a System Engineering and Test Leader at ULA, and Jennifer Buchli, Chief Scientist for the International Space Station Program. They will be taking questions live from our audience in the room, as well as using the hashtag AskNASA. So Jim, let's kick things off with you. You're currently the agency's Associate Administrator. Can you tell us a little bit about what that entails?
Sure, Tony. Thank you, and thank you all for being here today. In my role, I'm basically the COO of the agency, and the coolest part about that is I get to see all the missions that we do, and this is just one example of the cool things that we do, and really historic. And on behalf of the administrator and deputy administrator, thanks for being here today, and really for this whole panel. I really do hope you have some good questions for them. Because the work that they do is what really builds up our agency, our country, our nation, and our space program. And this is truly historic test flight, as you all know, and let me thank you for being here. I know you do this on your own resources. We don't take that for granted. Hopefully the behind-the-scenes look that you've seen really at multiple parts of our human spaceflight program today has just inspired you that much more. And I know I asked this question, I think, in the last social panel I did. I assume some of you have seen a launch before. Is that right? So you don't need advice, but I'll give it to you anyway. Like, set up your camera on a stand or something and just watch it and enjoy it. It is a beyond visual experience, as many of you know. It's a physical feeling when that pressure pulse starts hitting you. It's really incredible. And you know, if you've seen a crewed flight before, this one's going to be different. In the U.S. human space flight, we've launched this will be the sixth vehicle with crew. So it is really historic. And you know, we'll get there on Monday or whenever. Sunny said in our flight test readiness review that there's nothing magical about Monday. If we're not ready to go Monday, we'll go the next time. But we have to make sure we launch when we're ready. And I'm so glad that Sunny and Butch are on this crew. I just had the opportunity with the administrator and our agency chief of staff to go see Sunny and Butch about an hour and a half ago. And they are very excited. They had a lot to share with us about things that they're looking forward to on this mission. But I think they're mostly touched by the number of people that are truly excited to see them go to space, and very proud of the folks on the team that are going to get them there. You know, I think the partnerships that we've done with Boeing and SpaceX are an example of, for a crude flight, for cargo with other vendors, are just an example of really how NASA is stepping forward and really encouraging the commercial space industry, both for the International Space Station and for lunar exploration. You know, Starliner has a strong connection to Orion as well. So what you'll see in this mission, and especially when we return, there are many connections with some the hardware that's in the capsule. In particular, the parachutes are identical to what we're going to fly on Orion. So I always say to our crew members that are going to ISS, what you do is helping exploration as well, and we should never lose sight of what we're doing with the systems, but also what we learn about them when they're in space is going to help us for long duration exploration. That microgravity environment on Space Station really is unique, and you're going to hear more about that today and throughout the weekend, I hope. I know Jennifer has some great examples to share with you, and one I was just asking her about that we heard about last week. That is pretty cool. And all of this, in the end, helps us accomplish what NASA's mission really is, which is to explore the unknown in air and space, innovate for the benefit of humanity, and then inspire the world through discoveries. That's our 3 Ys at NASA: inspiration, national posture, and science. I am very fortunate to work with people that you see up here and really across our agency and our contractor community, and I really do hope you enjoy your time. So go Atlas, go Centaur, and go Starliner.
Thank you, Jim. Now, Ian, you're with Kennedy's Commercial Crew Program. Can you tell us a little bit about what the Commercial Crew Program is and what you do there?
So I serve as the deputy for the Launch Vehicle System Office, focusing mainly on our Atlas V, our Falcon 9, trying to get our astronauts up there safely, right, cost effectively. This is commercial crew, this is our opportunity here. This launch allows us to have a second partner, a second way up to station, which is spectacular. I think this is going to open up industry doors as well, right? This is going to provide us a future for low Earth orbit. This is a big launch for me personally. I've been with the Commercial Crew Program now since 2014. About 65% of my time has been spent on the Atlas Boeing side of the house. Familiar with this rocket. This is a long time coming. Like, this is you kind of feel the emotion, right? And kind of echoing what Jim said. When I come out to watch a launch on Monday, I'm going to stand out there. I'm going to put my phone down because I want to enjoy those 10 minutes, right? I want to feel those 10 minutes. But we've had a huge workforce. This was a big effort. This wasn't trivial. I mean, from a public standpoint, you get to see the rocket go, right? Looks great, but that was a huge effort to bring something that has not flown a human being on it, Atlas V, right? Bringing that into the fold, into a man-rated and a crew-rated vehicle. So this is a to coin a phrase from somebody in our office, a big dang deal for us. And so I look forward to this, and kind of want to echo what Jim just said. Go Atlas, go Centaur, and go Starliner.
Thank you, Ian. Yeah, we're all very much looking forward to launch. Now, Amy, can you talk to us a little bit about what you do at Boeing?
Yeah, again, just wanted to say it's so awesome to see everybody here. I attended a NASA social 8 years ago while I was in college, so it just feels like this full circle moment here. I'm so happy to see all this engagement with our launch. It's really a privilege to be able to give Butch and Sunny this great ride to space. So I work for Boeing. I work in our chief engineer's office as an associate chief engineer, and we get to help manage the technical baseline for the program. So what we do is we help manage risk and we help solve technical problems. And again, our focus is making sure Butch and Sunny get a great, safe ride to the International Space Station. So, kind of like Ian said, there's been a long road to get here. We've learned a lot, and this crewed flight test is going to be our next step in that learning. So we have 2 astronauts on board, both very accomplished individuals, both test pilots. They've been with us for a very long time and have been absolutely integral into developing Starliner into the vehicle that it is today. And so, again, just really feel privileged to be here and supporting the Starliner program. Looking forward to Monday.
Thank you, Amy, and welcome back. So happy to have you back on the NASA Social. Now, Caleb, you're working on the rocket side of things. Amy's on the spacecraft. Can you tell us now a little bit about your role at ULA?
Absolutely, yeah. So Caleb Weiss, System Engineering and Test Leader at ULA, and had the pleasure of being a mission manager for the Atlas V Starliner missions for about 6 years. And it was a really exciting time. We were developing all the interfaces for the spacecraft to the launch vehicle, mechanical, electrical, designing trajectories, figuring out the mission operations, and just everything you have to do to try to get a vehicle to space, and working with an incredible team with Boeing and NASA, and just a lot of fun. And I know that that ULA has launched rockets for a very long time, lots of payloads, but one thing that really I remember sticking out when I joined the Starliner program was being able to talk to the payload. We were working through a mission operations problem at one time, and we had the flight crew in the room, and we kind of scratched our heads on how to get through it, and we just asked the astronauts, hey, how would you want the rocket to fly in this kind of scenario? And that was the moment that hooked me, and I thought, this is so cool, working human space flight and getting to know that the person sitting next to me is actually going to go fly on the rocket. And so loved it ever since. Like I said, it's been a great team. We've done some incredible things with Atlas V. It's a very reliable vehicle, but took it to the next level with new crew safety systems. So we added an emergency detection system. We added a second engine to our Centaur 3, so we're going to be flying a dual-engine Centaur. That helps for crew safety and getting through abort zones faster. And overall, just really enjoyed working with this team. I hope that the conversation today inspires others to come join the space industry. It's a great place to be. It's a lot of fun. And lastly, I'll just say how honored ULA is to be the ride to space, to be the ones to be able to take Sonny and Butch and astronauts in the future to space. We have such a great team, completely dedicated to mission success and safety, and just couldn't be more humbled to be a part of this mission and be that ride. So looking forward to a great conversation today.
Thank you, Caleb. And now finally, but definitely not least, Jennifer, can you please tell us about your role and the role of science research on the International Space Station, which is where Starliner will be docking?
Thanks, Tony. I am the NASA ISS Program Chief Scientist, so I am responsible for the science strategy for the International Space Station. I also advise the ISS Program Manager on scientific matters. I advocate for the payloads, for the science, all the way throughout the program and up to headquarters. So I'm here today to talk a little bit about some of the science that we do on the International Space Station, but also I'm really excited to talk about the science being done by this crew. So the primary objective of this flight is obviously the test flight for Starliner, but our crew members also are conducting some human research on this mission as well. So having more crew members on the International Space Station means more science. We couldn't do the science that we do without the crew there to enable it. Just to kind of give a brief idea of how much the crew is doing to date on the International Space Station, we've done almost 4,000 investigations for almost 5,000 researchers. We have 250 active research facilities, and that's from over 100 different countries. So this crew in particular is going to be participating in some human research that is going to help with exploration. So the first investigation that they're doing is pilot egress fitness, which is designed to help us plan our missions back to the moon and also to Mars. So it's going to be taking a look at how they perform after the flight. We'll have pre and post-flight data, and then after landing, they're going to do a series of tests where they egress a ladder, as well as check their vestibular system, and then eventually with future crews that will evolve into them doing simulated EVAs. And then the next investigation, they're doing spacecraft occupant risk. So that is going to be one where we're taking data from the vehicle as well as from the crew to take a look at the loads that they experience coming back in for reentry and for landing.
Thank you all so much. Well, let's open up now the floor to questions. So who has a question? All right, we'll go ahead to this gentleman up front here.
With the delays that have happened with Starliner up until now, how beneficial is the impact going to be to commercial crew this late in the stage, since the end of life of the space station is coming? And in operational Starliner flights, are we going to be trading seats with the Russians like we do with the SpaceX Dragon crew capsule?
I can take part of it.
Yeah, that sounds great.
Amy, you can jump in there. I mean, the diversity of systems to give us access to space stations, very important, because you never know what can happen. We need to keep that continuous presence in low Earth orbit. So for us, it's great to have. You know, station right now is where we've agreed to fly it to 2030. There's a lot of time between now and 2030, and there's a lot of opportunities for us to continue the science that Jennifer talked about, the technology development that we need for those for the long-term missions. So from my perspective, that diversity, and we still need access to the station. To your second question, you know, our international partner have all decided a path that they'd like to go when they're ready to fly. They've all monitored and been part of our flight test readiness reviews for this launch, because it's still going to station, and anything that flies to station, our international partners have a say in that. Each of our partners will decide when they're ready to fly their crew members on this vehicle, much like they all made the evaluation for Dragon as well. But Amy, anything?
Yeah, definitely. I think it's a really interesting time to be working in the low Earth orbit economy. We're kind of seeing this boom happening in developing other low Earth orbit destinations. So, of course, the one we all think of is the NASA destination with ISS, but there are other companies as well that are developing their own orbiting laboratories. And so, you know, the Starliner program, the goal is to certify this vehicle so we can take humans to and from low Earth orbit safely. But ISS doesn't have to be the only destination for Starliner. So, of course, we're focused on providing, you know, our contract with NASA right now, but there are definitely other business opportunities that we're exploring. Good question.
Thank you. All right, I see we have a gentleman over here.
Hi, Tim Gagnon with KSCartist.com. My question is for Jim or Amy. The original crew flight test plan had a longer stay at station. Is there any scenario where you might, you know, with everything running smoothly, you might extend the stay for this crew on board station and delay their return?
I'll let Amy start.
Yeah, that sounds great. So right now, our minimum mission duration is based on the amount of work that we have to accomplish in order to satisfy the crewed flight test objectives. But we don't really have a constraint on the back end other than weather. So Starliner is a unique vehicle in that we land on land. And so we have to make sure that we have opportunities both at our primary landing site as well as our backup landing sites in the event something were to go awry. So really our primary constraint is landing weather. Now, we do, as Jim will probably talk to, there is availability on the ISS for Starliner to hang around. I'm sure Butch and Sunny wouldn't mind. But yeah, certainly the mission management team will make that decision to make sure we can come home safely. But right now there's no constraints for us to staying a little bit longer.
Yeah, I could not have said that any better.
Okay.
Let's switch.
All right, and I see someone there in the back.
Hi, Richard Howard from the Orlando Guy. My question is for Amy or anybody else on the panel that wants to answer. The challenges for Boeing to get to this point are well documented, and yet here we are. And in meeting with many of the Boeing employees on our tour today, the excitement is palpable. And I just want to know from your perspective, what is the mood from Team Boeing as you get set to make history on Monday night?
Pumped up, like seriously. It's you could just feel this buzz around the office. This is the closest we've gotten to crewed flight tests, so it's just been this enormous amount of effort. You know, folks that have been around for, you know, a long time have drawn from their experience from shuttle and space station, and now applying that to Starliner. Everybody's really, really excited. And speaking from experience, I've been on the program for about 5 years now. So you're right that we have learned a lot and overcome some challenges. Personally, I think it kind of just shows the resilience of the team as we've been able to work through those. And so for me, like, I think it's really awesome that Jim was able to talk to Butch and Sunny. They're really excited, which makes us really excited. So I'll actually be sitting on console launch day as the anomaly manager for CFT. So unfortunately, I won't have a window outside, but going to be too excited looking at all of our data. So very, very excited.
That's great.
Everybody, is extremely excited about this. Lots of people who have worked on it. I think, Jim, you said 6 vehicles total that have had human spaceflight programs, and to be part of the team that's one of those 6 is pretty amazing. So I can say that everybody, ULA, Boeing, NASA, is just pretty thrilled for this day to come.
Amazing. Let's take one more in the room before we go to social media questions. Perfect. We'll go over here.
Hi, guys. My name's Christian Zamis. I'm with Katora FXBG in Fredericksburg, Virginia. Speaking from an educational standpoint, if I'm a young person and I'm looking to get into working with NASA or with human spaceflight, is there a path that they should be looking into now? Because it used to be you would go into the Air Force and then or into the Navy and become an astronaut. But there seems to be so many more people here on site that could help be a part of that machine, a part of that system. And you guys are doing such a great job of supporting those people. Everyone like we've talked to today is very excited to be a part of this, and they seem to feel valued. So I know that's important to my littles at least. They want to be heard. So do you have a suggestion for me? Or for them?
I mean, I don't mind starting from definitely the oldest person on here. We have 40, I don't know the exact number, 40 some astronauts in the crew office today. Not all of them went through the military to get there, right? We have I think the new astronauts that graduated just a little bit ago. We have someone that worked in the oil industry. We have medical doctors. We have biologists. We need those kind of folks because those are the fields that we're going to do, and we need to understand for exploration. We need all of those elements. So we far outnumber the astronauts in what we do, and I didn't go that route. I went to engineering school and got a job with NASA right out of school because it's what I was passionate about. There's certainly the commercial space industry has changed a lot, and actually we have trouble keeping a lot of our workforce here who go to work for other companies that are nearby. But ultimately that helps the space industry. We have contracts with those folks. So I think it's a great time to want to get into it, but I'm on the latter part of my career, talk to the folks on the other side.
I'll take a stab at it. So I have a little. My daughter wants to be an astronaut, and so she asks me all the time, how do I be an astronaut? And so okay, we'll ride some roller coasters, get used to that first, right? You talked a little bit about military, but there's the other aspect of it, right? There's engineers, there's folks that are doing public affairs. Like you've probably met a sundry of folks out here that cover all sorts of different knowledge levels and activities, right? But I'm going to even take it a step back. It's what you guys are doing, how you guys are advertising, how you guys are promoting, how you guys are making a deal of this, right? We're getting space back out there again. We're letting people know that it's not just about here on this earth, right? Let's go explore. Let's go do what we were built to do. So I turn and look at you and say, I think you guys are the key on why so many of our kids and other people want to get involved with NASA is because you're out here doing your advertising and you're out here representing us and helping spread the word for everybody. So I'd like to say thank y'all to y'all.
I'll echo what Ian said about diversity of background at NASA. You know, I think sometimes there's a misconception that it's only for scientists and engineers. You know, we are a large team from a wide variety of different educational backgrounds. So personally, I encourage people to study what they love and what they're passionate about, and there's a place for you to contribute here at NASA. I'll also add we have a number of student programs starting, you know, as early as outreach to, you know, young elementary school children. We start mentoring in high school. We have a variety of internships, and we even have competitions for high school students to fly experiments on the International Space Station. So there are a lot of options out there.
Thank you. And as a non-engineer or scientist, I still love NASA, so definitely a place here for everyone. All right, let's take some questions from social media. So Orion Space on YouTube asks, will Vulcan launch Starliner, or will it only be by these few remaining Atlas Vs launching it?
I hope so. Vulcan's a great vehicle. Would love to see Starliner on top someday. We're absolutely focused on the Atlas missions, though, right now. You know, we may open up some new mission space someday, but the nice thing with Vulcan is we had the experience of having human-rated Atlas. So within ULA, we know what it takes to human-rate a rocket. We've made sure that as we design Vulcan, we're not precluding human space flight. But just like what I talked about with Atlas and in adding some of those additional systems, we would need to do that with Vulcan, and we may someday. I don't know exactly when, but we might.
Awesome, exciting times. Let's take another question from social media. Natasha on Instagram asks, what is the most exciting research the astronauts will conduct on this mission? So I guess maybe that's a personal, which do you think is the most exciting?
This is always a dangerous question. Sometimes people ask, what's your favorite experiment? And it's probably like asking people to pick their favorite child, so I usually try and steer around that one. So, you know, I think the fact that these astronauts choose to participate in human research, by the way, so that's always their choice. I think the fact that they've selected human research program experiments really speaks volumes to how important it is to them and some of their contributions to exploration research. You know, we talked a little bit about the pilot egress fitness study earlier, where they're doing an egress and simulated EVAs eventually. I'm really excited also about the spacecraft occupant risk one. This really helps us collect more data and build more models to design future spacecraft and make it safer for everyone. So this will take a look at some of the forces that crew experience, very similar to how people do this in the auto industry. And so I think this is really important as we see more companies come online and more people join us in space.
Yeah, it'll be very interesting to learn what comes from that. Fox McCloud on YouTube asks, how will Boeing's Starliner contribute to the commercialization of low Earth orbit, and will it contribute to crew trips to Mars?
Yeah, so the Starliner platform is focused on low Earth orbit economy. As I kind of mentioned in a previous question, that the cool thing is, again, we're in this really awesome time of space exploration where NASA's kind of pivoted their focus more towards destinations farther than low Earth orbit. So they've really kind of handed over the keys to a lot of different commercial providers to help keep ISS running, as well as other low Earth orbit destinations. So Starliner has the capability to basically dock with anybody that's available. So we're looking forward to, after we're flying our crewed flight test, we're looking forward to continuing that business case.
Very neat. All right, now before we take more questions online, let's see, does anybody else in the room have any other questions? Great, let's go over here up front.
With all of the entities involved in this particular mission, what does it take for you all to communicate with each other effectively?
Good question. I can talk a little bit about launch day, because that's just like the coolest orchestrated event I think I've ever witnessed. You know, there are, as you mentioned, a multitude of organizations that are involved, and they kind of all have their different roles and responsibilities depending on, you know, who you're talking to. So the range is responsible for public safety and making sure, you know, we're good to launch. Of course, the ULA side of the house makes sure the rocket's healthy. Starliner on the Boeing side, we make sure that the spacecraft's healthy. And then NASA helps advise in other capacities as well. So we do have communication loops that have kind of regimented like points of discussion depending on what you're talking about. So we have a dedicated anomaly loop if something were to go wrong, and we have like an integrated discussion with either the International Space Station or with the rocket where we need to resolve something. It gets really exciting when you're getting down to the final launch countdown. You really hope for a quiet launch countdown, right? If things are quiet on the loops, it's actually a great day. But that's really on the launch day. There's a level of hierarchy that you go through for decisions, those types of things, and I'll leave it forward to anybody else.
Yeah, the launch day is the one aspect, and then I go further back into the certification. Like Caleb and I worked together for OFT and OFT2. We've worked together with Boeing. Like the three, even though we're three separate groups, you have to come together because we're poring over the data. We're poring over the vehicle and understanding, you know, what it takes to crew rate a rocket. And so to me, that is, we're getting all in a room. And, you know, some of this was during, you know, COVID times, right? So we had to adapt. We had to change how we did business and how we do video calls and work together. But the one thing that was in my mind is we kind of put our badges aside for a second. We were unified in a goal. Our goal is to get our astronauts up, right, safely. That's our goal. And so we put everything else aside and we focused on that effort, the three groups. And that to me is where, yeah, I love the launch day part where it's like you're listening and all good, but just leading up to that was truly, for me, really exciting, seeing the brain power of three different groups coming together and solving the problem.
Yeah, and one other thing I'll add is the system engineer on the panel it's robust system engineering, right? We have to have, you know, lots of communication, obviously, in person, but at the end of the day, it all gets written down, documented. We have requirements between each other. We have to go verify those. We have to have very robust systems engineering processes. So you hear a lot about a mechanical engineer or a propulsion engineer. Well, a systems engineer's job is to actually do that integration between teams and make sure that the entire system is coming together and ready to go. So it's a process that all of us take very seriously and have large system engineering teams within our organizations.
Lots of communication. All right, let's take another one in the room. I think we have one up here up front.
Thank you so much for doing this. So once Starliner launches and lands and you pour over all that data, it'll kind of be the conclusion to over a decade of work in the commercial crew program to bring these two vehicles, Dragon and Starliner, up to snuff for NASA and low Earth orbit. What is NASA going to be taking from this experience when it comes to certifying future crew vehicles? Because hopefully these won't be the last ones. And how will NASA work with commercial partners who may not have originally been with the commercial program to certify new vehicles?
Yeah, I mean, I can start. Any of you can add from your experience. We have a set of human rating requirements that we continually develop. Some of those are taken and tailored for a particular vehicle that we might be using. So Orion has a set derived from those requirements. Starliner's requirements are based on that. Dragon, what we're doing for human lander, anything we put the crew in or on, or even what they interface with, has a set of requirements that have to be designed to, verified to, and then they feed up through the certification of flight readiness process that was referred to earlier. So we always evolve those. We actually talked just in the conversation with Butch and Sonny today, they were talking about a test that they advocated for in the process, the crew validation test, crew verification test. Their advocacy for that helped us say, hey, I think we need to do something similar for Orion. So it's this constant feedback loop that we do from a lessons learned perspective. And by the way, we've been doing that for 25 years in orbit with Space Station, constantly learning about how crews learn, and we can improve the design of our vehicles and the operation of our spacecraft for the future. But any of you can weigh in.
I mean, that's So basically, each opportunity we've been given kind of trimmed down, we slim the roadmap, right? You really get your directions honed in a little bit more, direction you want to go and how you want to get there, right? And so you start realizing the lessons learned is the big part. What can we share with the rest of industry that we've learned? And we've now simplified a process to where if another vehicle, let's say launch vehicle comes online, I've got a good roadmap. Like I've got something that I've learned, ooh, that didn't work here, but it worked here, or we took this path and this worked really well here, and now I can streamline it. We become more efficient, right? So heavy on the lessons learned, definitely.
Yeah, and learning never finishes, ever.
Great. Anybody else in the room? Awesome.
Hello, I'm Tony Boyd. Thanks for allowing us to be here, for one. I wanted to talk about the crew, okay? How do you go about selecting the crew, and who is basically in control of the crew? Are they NASA astronauts? Are they Boeing astronauts? How does that communication chain of command go?
So I'll go the selection route. They're NASA astronauts, okay? I'll let Amy and Ian talk about how it works as we buy this vehicle as a service. Selection of the crew, first of all, to be an astronaut, you go through quite a selection process. That selection process is run by the Johnson Space Center and the Flight Operations Directorate and the crew office at Johnson. The specific selection of crews for a flight also is run by the Johnson Space Center. And we take a set of, here's what we need to do on the mission. In this case, you've heard a lot about what we need to do on this mission to certify the vehicle. What we need to do once we get to space station with the tests that we'll run there. They're going to do some manual operation of this vehicle, so you want folks that have that kind of experience. And then you match the crew office and you say who has those skills, and that's how that selection process is made. There isn't a, hey, it'd really be cool if this person flew for some reason that doesn't have a mission connection, because ultimately these crews are putting their lives on the line, putting their lives in our hands to make sure we've done that work. So we want them best prepared to do the tasks that we need, and then that goes against their skill level. These are both test pilots, as was highlighted before. First time you fly a vehicle, there's a lot of things you learn that they learn as test pilots. But our other crews go through a lot of training that they can understand how to identify those. These two test pilots on a test flight happen to be the best fit. But I don't know, Amy, if you want to talk about it, or Ian.
Put it very, very well. As was mentioned, like a test pilot mentality, it is a very specific kind of person. You think about things differently. And so when I talked about Butch and Sunny being involved in our development before, it's been crucial to have them there to think about the user in our vehicle and how they interact. And so, as was mentioned by Jim, during this flight, we will be demonstrating Starliner's manual capability. So in theory, astronauts that ride aboard Starliner would be able to sit on their hands and just kind of watch as the vehicle does its thing, docks autonomously, undocks autonomously, and lands autonomously. In the event something were to go wrong, the crew has the capability to step in both the instance of still having our flight computers kind of driving the ship, but the astronauts giving manual inputs, and in the instance of we completely lose our flight computers and they fly stick and rudder, basically. So having these two individuals who've got an enormous amount of experience in that type of domain is really, really helpful. And so, of course, we're happy to accept anybody who's going to fly on Starliner, but Butch and Sunny were an awesome fit for CFT.
Thank you. All right, we'll take another one in the room right here up front.
You mentioned a lot about data, you mentioned a lot about communication, and you mentioned a lot about the importance of launch day. My question to you guys are, how important is communication and keeping the data out of silos when launch day is over and they return home? And how often, or I won't say how often, how quickly do you flip that data and go into using that for future products or experiences?
I can talk about our OFT2 learning if that helps. So obviously this is not the first flight of Starliner. So we have had a couple uncrewed missions, Orbital Flight Test 1 and Orbital Flight Test 2 in 2019 and 2022 respectively. So this CFT vehicle is incorporating those lessons learned. So I'd say the process is pretty immediate. If we learn something on orbit, for example, we're going to talk about it on the loops, and then if we need to operate differently, we can do it real time in the mission. Now, if we, when the vehicle comes back and we are poring over the more detailed data that was recorded kind of in passing as the vehicle was going through major events, if we find something that's unexpected, that gets talked about, and we come up with a plan to resolve that and then fix it on the next vehicle. I think a really good example is our oxidizer valves that we learned were susceptible to moisture. So for our first attempt of Orbital Flight Test 2, we had valves that stuck on launch day, and so we had to immediately fix that problem in order to go fly again. And so the team rallied together, got an integrated solution implemented for OFT2 and CFT as well, again, to prevent that susceptibility to any corrosion forming and those valves not operating. We need those valves to operate in order to make sure Starliner is safe. So I'd say the process is pretty immediate. And then we can also look at things that are maybe not necessarily required to make sure that the spacecraft's safe, but hey, that would be kind of nice to have if it looked this way or if it operated this way. We can look at implementing those in some more of like a longer term type implementation, and I'll leave it to anybody else.
Yeah, I mean, it's almost like a seamless flip, because part of your next mission and your next readiness is going back and look to see what happened before, right? And so I can tell you, like from a launch vehicle standpoint at Commercial Crew, we've already started, I've got CFT out there, but I've already started working Starliner 1, right? We've already started putting those pieces together. What do I need to go look at? What do I need to be involved in? What are my mission reviews? What are my hazards? We've already started, what are the design changes? We've already started that process. And so we'll launch CFT. Our awesome ULA team will pour through all that data, right? And then come back and say, hey, here's what we got. And it's just part of our flow, right? It seamlessly goes in, and anything that comes up, hey, we get right to work and we start addressing that in addition to getting ready for the next flight.
And one other thing I'll add is just the rigor that's put into it. So this is the 100th Atlas V flight. Pretty excited to celebrate that as part of this launch. And we have reviewed the data from all 99 atlases before and made sure that every single thing is dispositioned, that we understand all the data, that anything that doesn't look right is investigated and dispositioned. And so we don't, we never get to a point where we slow down on the data review. Even when you're up to your 100th vehicle, you are still reviewing that data with the same rigor that you did the first and making sure that that vehicle is ready to go and safe to fly, and that's what we're doing right now and have done for months.
For someone that doesn't understand what loops is, could you clarify?
Yeah.
Thank you.
So the question was, I mentioned before that we have communication loops, definitely lingo talk for some of the human spaceflight world, but basically they're communication channels. So they're like dedicated channels that certain folks have access to have particular discussions. So, we do not want it to be a free-for-all on that day, given that there's so many orchestrated events that we have to go through and make sure that we're kind of progressing in an orderly manner. So to have dedicated areas of discussion, basically, loops is just another term for channel. Good question. Yeah. Yeah, exactly. Or subreddits, yes. Yeah.
Thanks for clarifying. Yeah, sometimes we have our own NASA lingo, I like to call it. All right, we'll take another person in the room. I think we had that gentleman there in the middle.
Good afternoon, Kai Billings from Create Force. The number of complex systems involved in sending a crew to space seems to be increasing every day, and with that increases manpower. So how decentralizes your decision-making for your teams to enable them to take risks and own their decisions, but also not necessarily put the mission at risk?
So I'll talk about the Boeing portion of the house and toss it over to, because I think each organization has their own way of how they manage their risk. However, if it does have some sort of like broad, like overarching mission impact, we as a community have to come together and all agree that this risk that we would be taking is acceptable to everybody, not just one organization feels it's acceptable and the others do not. So, you know, on the Boeing side, we really empower our engineers to roll up their sleeves and get into the system that they're working on. And then, you know, if they feel like they're seeing something that's unexpected or non-conforming or what have you, you know, we have our process to go elevate through our engineering chains and program management chains to talk about those types of things. And again, anything that's loss of crew, loss of mission, anything that would affect, you know, the overall mission performance, absolutely that has to get talked about on a broad scale and make sure everybody understands that data. And then we can bring that story to either our ULA partner or NASA partner to talk about it and make sure, again, the collective community all agrees that we're still in an appropriate place. I think many folks have heard before, human spaceflight is all risk management. It's always risky, right? It's just the level of risk that's acceptable to go fly a flight. Feel free to.
Yeah, so I can say on our side, you know, you're right, it is complex. And in that complexity, now you have to be very integrated, right? It's not just necessarily a launch vehicle issue. It's something that's going to impact the entire integrated stack and assembly. So one, you know, from our side of the house, it's a speak up approach, right? See something, speak up. You know, we have all sorts of different avenues and boards to have the conversation. And not only is it just the NASA folks, but we bring in our technical experts at both Boeing and ULA. Say, hey, we see this. What about this? What did this change? You know, piece of complexity, something like software comes in here. You know, there's unintended consequences. And sometimes you find that through our robust testing. And so we've got to sit down and we've got to really analyze that. So you're absolutely right. Complex systems just means that we need to be more integrated, right? And so we reach out and this becomes earlier when I mentioned, even though we're separate, we got separate badges, we're all one group, right? And this is how you have to do it. You speak up and you start pouring into the data.
And at ULA, we have a very similar process with, you know, all the engineers are empowered. They're going to be reviewing their data, watching their screens on launch day. They're going to make sure, though, that if data starts to fall outside of the box that, you know, they've been given to make a decision within, then it gets elevated. And the one thing I'll add, just as that data does get elevated, is that we have the Mission Directors Center in the ULA ASOC, and we have the Mission Director, who is Leroy Kane from Boeing, sitting right next to our Launch Director, Tom Heater at ULA. So there is a lot of communication going on the loops, but there's also communication in the room, and that we've chosen to make sure that we put key people next to each other, as well as we have the NASA program manager, Steve Stitch, in there. We have the ISS program manager, all sitting together so that we can have, you know, fast conversations and make quick decisions if needed.
Thank you. I think we had one more person in the room. Oh, looks like we actually have a couple few. We'll take this person right here.
Hi, thank you for putting this on again. This has been great so far. I'm Brandon Hanna with Film Physics, and I just wanted to ask, you talked a lot about the importance of diversification with crewed spaceflight vehicles amongst different companies in the industry, all collaborating with NASA, and how that all works in with lessons learned and the importance of that. So I was just wondering if there was any cross-industry collaborations between companies like SpaceX and Boeing with some of those lessons learned to kind of help uplift the entire industry and NASA as a whole.
Yeah, I'll speak just about the we share our lessons learned. Obviously, if it gets into a company proprietary thing, then if it's going to affect human life, we're going to share it. When it gets into the company proprietary, we have to respect that side of things. But from our perspective, it's much like our science data. We're going to share it because, in this case, it really affects human safety. But and you probably live it more than I do. You're in CCP.
Yeah. So along the same lines, I mean, you know, one of the interesting parts that I've had is I've been able to actually work both partners, right? And so we see things, and it's I need to respect the information, the proprietariness of it, clearly, these commercial entities. But there's a certain level of which, as Jim said, there's a safety part to it. And it's like, I can't even give a really great example, right? But there's something here, and I just want to make sure that you guys over here are looking or thinking about that as well. Right, and that is the lessons learned, and it's not just the two partners that we have in Commercial Crew Program, but it's also Artemis. It's also these other groups in commercial industries that we want to share that. Hey, have you really thought about the effects of X, Y, Z? Right, and this is what NASA has picked up, and it's benefit of all of us if we just share this quick piece of lessons learned at a high level, right?
Yeah, no sense in learning the same lesson twice, basically, or more than twice.
Preferably.
Yeah.
Thank you, and I think we had time for one quick question in the room, so we'll go to you.
Hi, Jack with NASA Social. Since we're talking about the crew safety, I understand that Atlas V has a 100% success rate. But in the event of an in-flight abort, which I understand we have to have these just-in-case scenarios, Starliner would be doing a splashdown, and how quickly can the crew be rescued? Yeah,
so I'll take that question, at least from the spacecraft side. The great thing about the ULA trajectory is that we have the ability to abort all along our ascent profile, and that was very specifically designed in, as a learning from past programs. So there's kind of different areas you can abort into depending on how far along you are in your ascent trajectory. You will more likely than not land in the ocean along the East Coast or potentially as far as Shannon, Ireland. If you listen on launch day to the loops, they'll be calling out kind of as they pass through those different phases of aborts. And so we have this requirement to be able to maintain, crew health for 24 hours. In the event something, they land in the ocean and far away in Shannon, Ireland, we have to go coordinate all that. But the benefit of landing on land, if we do get to orbit and something is wrong where we do need to come home very quickly, we actually, the Boeing team has pre-staged folks out at the landing sites in the American Southwest that we would be able to get to them within 30 minutes. So the answer depends a little bit, but the ULA side.
Yeah, to just talk more about the trajectory, again, we did design it to be the least risk possible we could in an abort scenario. And so that's where I talked about the dual engine Centaur before. We basically doubled the thrust on Centaur, which means we get to orbit faster. It gets us out of some undesirable abort zones. We don't want to be, we don't want to have the crew coming down in the North Atlantic or somewhere where it does take a long time to reach. So really design the vehicle to decrease that time as much as we can, and so that in the event of an abort, you can get out there and get them home quickly. And so that's really a feature of the vehicle that we've designed in. The abort, we have the emergency detection system on the vehicle, and so just like Amy said, we are tracking the abort zone the entire time we fly, and we'll know right where it is if it were to occur.
And you can't just have good weather at where you're launching. You have to have good weather all the way along your trajectory. So everybody do your rain dance.
And just to add, we have partners in the Department of Defense, the pararescue jumpers who support all of our human spaceflight launches. They're pre-deployed and ready to go with their equipment to support an abort. We need them here locally as well if we do a pad abort and up the corridor, so they're ready to go with their equipment. And should we have an abort, we can get them there quickly. As Amy said, the vehicle is designed to be there and keep that crew safe until we can get them there. But they're ready to go and train on every one of our the two partners for Commercial Crew and Artemis.
Can we end on a non-abort question?
We actually have time for one more question. We're going to take it from social. DUGGLA on X asks, how does it feel to be part of history-making space missions? And Jennifer, if you want, we'll start with you, and then we can just go down the line.
Wow. It feels great. I think people have talked a lot about the teamwork that is involved in these missions. And so, while I think everyone takes a lot of pride in their contribution to that, it just has an incredible energy to be sharing this experience with the folks here at NASA, with our commercial partners, with coming from Johnson, right? With a lot of your friends that you work with. A lot of folks have gotten to know the crew members who are going to be on board. So I'm really excited to see this launch on Monday, and very proud to be here.
Yeah, space is cool. It's so much fun to work in. The team has a common mission. I mean, it's hard to find many other industries where you have that common mission, where every single person on the team is aligned to getting humans safely to space and back to Earth. And so it's such a fun environment to work in. Extremely excited about it. Just a great organizations that we're working with, super dedicated teams, and just really excited to be part of it.
Definitely echo the pride. There's just an immense sense of pride for where we are today. And then I'd say it's pretty humbling. I think we all acknowledge that we're standing on the shoulders of giants here. There have been a lot of programs that have come before us, and so this is just another step. And definitely, it's kind of cool to be able to say that we're launching our friends into space. So
it's the capstone to a tremendous effort by tons of people in countless hours, and across multiple, not just the companies, but multiple centers, our Marshall counterparts, our JSC counterparts. I mean, we've got people all over this nation who have touched this in some way. And personally, I'm just proud to be part of this. I'm proud to be, having a team that's involved. I'm proud to be able to work with these two great organizations, right? I had the pleasure of working shuttle. This is my first time with a brand new effort, especially for like Atlas and putting Starliner on top and going. So there will be tears. I'm not gonna lie, there will be tears, right? I'll man up right now. There will be tears.
Yeah, it's incredibly exciting. I mean, you see the quality of people, just one snapshot of the folks that work on these programs. And it's incredibly exciting to work with people with this kind of talent, to do things that really are changing human history, is what's happening. It is incredibly emotional to be part of it. And Amy said the best word, it's humbling. You have to keep the highs in check, because ultimately what matters is when you get those people out of the capsule and they land, and you keep them safe every day that they're in orbit. So it's kind of quite a range of emotions.
Thank you. Well, those are all the time. That's all the questions we have time for. Thank you to all of our panelists who joined us here today, and thank you for everyone in the room and who joined us online. Now, set a calendar reminder for CFT. Again, that's scheduled for Monday, May 6th at 10:34 p.m. Eastern Time aboard a ULA Atlas V rocket. Launch coverage will begin at 6:30 p.m. Eastern Time on NASA Plus and nasa.gov/NASA Live. Hope you can join us.